Hello, in this video I would like to introduce you to our new packet parser features. So you can access the packet parser with adding a new interface, packet parser, and when you want to add a new module, you can choose the protocol HTTP, TCP, UDP, or FTP. We will start with HTTP. You need to choose an IP address of the device you are connecting to. In my case, it's 99. So I have a new HTTP parser module, which is connecting to IP address on port 80. And I can choose some service settings like user, password, authentication type, and so on. My module is Shelly plug. It's a smart plug which can be turned on or off, and also shows how much power it's consuming. So I will rename it to Shelly. Okay, save. On the module, I can add variables. These variables are accessible then to the devices, and I want to add a new device for this module. We know that it is plug, so it's a digital output. It's a relay, which we can turn on or off. Now I have a device, and I need to set for this device scripts. For a relay, we have read digital output and write digital output. So when I want to read the status of the device, I will use the read script. Here is some predefined code. You can just simply uncomment the example and use it. So this simple HTTP request is doing that. It's sending the request to this on the IP which is defined in the module to this path. So for me, when I check the Shell documentation, it's I will read the status from the relay 0. As you can see in web browser, when I read the relay 0, I am getting JSON with the information about the relay. So I will put this address here. Then it continues to parse JSON. The first thing is that the HTTP request response is it's in itself is JSON from which I can read if it was successful, and then I will parse the content of the response. And when the return was, if it was success, I will read the content, and the content for me is not XML but JSON, so I will parse JSON. And I can see that the status of the relays is on. So I will need this element is on. And if the request was not successful, I will add error with the status code of the response. Okay, we can test it. So I will save it. And when I will turn it on, it should turn on in the application. Also, when I turn it off, the status is it's reading the status from the JSON. And there is the polling interval, which you can set on the read script. So I have set it as a default for 2.5 seconds. So this is the reading part, but when I want to modify turn it on and off from the application, I also need to set up write script. We have also some simple example. So I will uncomment it. It is even more simple. There is just one send HTTP request with the value of the desired value of the switch, and then the testing if the response was success or not. If it was not successful, I will add error. So I will need to set up the path for the plug. You can see in the documentation that there is a parameter that is the turn. It accepts on or off. I can test it in the browser. So if I put the turn on, I should see the Shelly plug is turned on. When I turn it off, the plug, okay, it's all not like this, off, should be off now, yeah, it is. So I will need this path in my HTTP request. And the value in the in the st variable is just 0 or 1. I'm not sure if it will work with Shelly. We can test it in browser. So if I put it 1, no. So it needs to be the text. So I will need to translate this variable st to on or off. And I can do it with if statement. So if the st is equals 0, or if it equals 1, it will return on. Oh no. Otherwise it will be off. Off. Okay. Let's test it. Save. Look at the shell interface. So when I turn it on in application, it turns on the Shelly plug. When I turn it off, it turns off the Shelly. There are some more properties you can set. You can set variables for the device. As I said before, you can set variables in the module also. These module variables are visible for all the devices in the module, but the devices, the variables in device are visible only for the specific module. Sorry, for the device. Here are some the service attributes and service actions. When you define service attributes and actions, they will be seen, they will be added to this screen for service settings. So I can read, for example, the status of that, if it's overpowered, and I want to see it in the service settings. So I will take this read script and I will define new service attribute. Named overpower. And the rescript will go here. And it's the same same address, so relay 0, but I don't want to read ISON, but overpower. No, something, okay. There is no support for errors in here, so we can't add error in service attributes. Let's test it. When I save it and go to service settings, I will see new attribute, my custom defined attribute, which has now value of false, like here. When I define all my devices for that module, I can export it and reuse the same settings somewhere else, and I can do it in the module and save it as a template. It will save it as an XML file, which I can then import on some other installation. Also, we have predefined templates for some devices. They are managed on GitHub repository, which is Tabhom official packet parser templates. You can see there are some, this is some Shelly, or Lightning, E-Light color, and so on. This project is public, repository is public, so anybody can contribute their templates. It's managed by us, so we will check that if the template is correct and add it to the repository, so anybody can use it and share it. There is also the repository for Modbus templates and packet parser templates. And that's about it. Thank you for your attention.